Lesson 5-4. Our learning target today is I can solve a compound inequality. Our essential question says, what are the three types of graphs that may represent a compound and inequality? The key word there is and. A compound inequality is similar to a compound word. A compound word is when you take two words and you put them together to make a new word. A compound inequality means you're taking two or more inequalities and joining them together to make a compound inequality. Now, the key word today that's connecting the inequalities together is the word and. The significance of the word and is that and represents an intersection of two sets or an overlap. So we're going to be looking at two inequalities and then looking for where they overlap with each other. So it's kind of like when you look at groups of people, like an intersection might be taking like the 8th grade class and then taking all of the students that are involved in theater. And the intersection would be the 8th graders that are in theater. So an intersection means that you're part of more than one group. And in this case, more than one inequality. All right, type 1. So we have three different types that we're going to be learning about today. The first type is called an interval graph. So we have two inequalities. X is less than 1 and x is less than or equal to 5. I'm going to graph these inequalities individually, but I'm going to make sure that I line them up. So watch what I do. My two numbers are 1 and 5. So that means that I want both of my number lines to have 1 and 5 on them, and I want them lined up because this is really important for the visual piece. So my first inequality, x is greater than 1, would be an open circle with a ray pointing to the right where numbers are greater. My second one is x is less than or equal to 5, so that will be a closed circle to the left where numbers are smaller. Now, because the key word here is and, we're looking for where they overlap or their intersection. So numbers that are on the first ray and the second ray. So watch the visual as I move my other ray up. Can you see the numbers that are on both of the rays? Hopefully you can. So if I draw a graph to represent the numbers that are on both of the rays, still using the same numbers, that overlap started at 1 with an open circle, and it ended at 5 with a closed circle like that. It did not continue beyond the 1 or beyond the 5 because those values were not on both. Of the inequalities. Now, I also need to write an inequality to go with this graph. So there are two pieces here to the solution. To write the inequality in interval form, it starts at 1 and it ends at 5. X can be anywhere in between 1 and 5. Now, I'm going to look at my original inequality over here for my symbol. X is less than or equal to 5. X is less than or equal to 5, like that. Then I want you to notice that the 1 and the x are not in the same order. So I'm going to need to turn this inequality around, making it look backwards, in order to figure out the symbol between the 1 and the x. So be careful. Notice that my inequality symbols both ended up as less thans because of the order that it's written. So this is a compound inequality. This is an interval notation, and an interval graph. All right, type 2 is called array. Array. So I'm going to start by circling my numbers. This time I need -1 to 3. So -1 to 3. I'm drawing both of them and lining them up again. The first one is greater than -1, so open circle to the right. The second one, greater than or equal to 3, closed circle, but also going to the right. So what happens this time as we look for the intersection? If I move this up to visualize it, do you see that where they intersect, where they overlap, starts at the number 3? So this time our graph is not an interval, it is just a ray. And the ray happens to start at 3 and go to the right. It doesn't start at 1 because starting at 1, those numbers are not on both of the rays. They're only on one of them. So our ray starts at 3, so then the inequality simply matches the second one. X is greater than or equal to 3. So this is our solution. Okay. Third type. The third type is called an empty set. This one says x is greater than 6 and x is less than 2. So draw each ray. This time I go from 2 to 6, 2 to 6. And just draw my third one right away. From 2 to 6. Greater than 6 is an open circle to the right. Less than 2 is an open circle to the left. Now, if you take a look at these rays, because I've got my graphs lined up, you should be able to see that they don't overlap. They don't overlap at all. So what that means is this is called an empty set. There's nothing that you can graph, nothing at all. It's an empty set. So there are no values. Think about this. There are no values that are greater than 6 and less than 2 at the same time. That's not possible. It's not possible for a number to be both greater than 6 and less than 2. All right. Now that we've seen all three types of graphs, we will have some problems that you need to solve and graph. So, putting together our skills for solving inequalities with our new found skill of solving and graphing compound inequalities, we are going to solve and graph. So these are two-step inequalities. So my first one, I would need to subtract 1 on both sides, and then divide by 5. So x is greater than or equal to 1. Remember, you don't want to start drawing your graphs until you know both of your numbers. The second one, I need to add 7. So 3x is less than or equal to 12. Then divide by 3. So x is less than or equal to 4. Okay, so now my numbers are 1 and 4. So the first one goes from 1 to 4. Second one also 1 to 4. And the third one. Okay, so the first one, greater than or equal to 1, closed circle, going to the right. Second one, less than or equal to 4, closed circle, going to the left. Now, because our connecting word is and, we're looking for where they overlap. So take a look at that. And this one is creating an interval from 1 to 4. So closed circle on 1 to a closed circle on 4. And then writing the inequality to go with it. Remember, we can look at our inequalities. It starts at 1 and it ends at 4. The x goes in the middle. We're combining this to write one compound inequality. So my first one up here, x is less than or equal to 4, looks good. My second one, notice that x is greater than or equal to 1. So if I'm going to reverse the order here, that means flipping it around so that it's a less than or equal to. It points at the 1. So here's my solution. Interval graph and compound interval inequality. And that was my last example. So there are three different types of situations for compound inequalities that are connected with the word and.